All right. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
All right. Good afternoon, everyone. I hope you're good today. So today is the extra lesson for you because next week we're going to have the exams. So we need at least 1 hour to finish the topic. So without wasting the time, because I know that this weekend, maybe you have some program with your family or with your hubby. So let's start directly. Inshallah, it will not take a long time, maybe only one session you're going to do. All right, I'm going to start with this question. All right, no problem. Ifan. I'm going to start with this question. We are going to remember how to use the KC here. Right, this question, maybe you can write the question in your notebook also. Example 9, a 3-mole sample of N2O5 was placed and heated in a 1-liter vessel. Some of N2O5 decomposed according to the reaction, blah, blah, blah. At equilibrium, the total mole number of gases was found to be 3.75. Calculate the value of Kc for this reaction. All right. Okay. Let me show you how to solve this one. As usual, to solve this equation, you have to write down first the reaction. 2N2O5 and equilibrium 4NO2 plus O2, right? And we're going to write ICE, all right? Now, what is given here? 3 mole of sample. So it will be in initial, change, or equilibrium.
Siap.
Initial. It must be 3 mole here. 3 mole here. And initially, of course, the product will be 0. And in the changing, we have negative. In a product, we have positive, positive. All right. Now here say that some of N2O5 decomposed, but we don't know how much it will be decomposed. And it's mean that we will not find the C because it is not given here the percentage or any amount of substance. It is not given in the equation. So what should we do if it is not given? We're going to write here in the changing.
X.
Yeah. I'm going to write here, for example, let's use this coefficient to make it easy, right? So because the coefficient 2, then I'm going to write here 2x. Now coefficient, this is 4. Let me write here 4x. And here it is x, isn't it? Now we have this kind of matrix. Now let's find the equilibrium by summing this one. So it is 3 minus 2x for the N2O5. This is 4x here, and this is x here. Now we're going to find the x. How are we going to find the x? Here, given in the equation, the total mole number of gases was found to be 3.75 at equilibrium. So when I add this, all of them at equilibrium is 3.75. So it must be like this: 3 minus 2x plus 4x plus x is equal to 3.75, isn't it? Okay, let's do the operation here now. So 3, it is 3 minus 2x plus 2x plus 3x, yeah, plus 3x is equal to 3.75. So 3x is equal to 0.75. So x will be equal to 0.25. I get the x. If I get the x, then I can find here the value of the N2O5 here. 2 times 0.25, 0.5. So it is 2.5 mole here. 2.5 mole. Here, berapa ini? 1 mole, isn't it? 1 mole here, because 4 times 0.25. Here, x is 0.25 mole. Now here I get the mole, and because the volume is 1, so the mole will be equal to the molarity, right? So after we find this, it is easy now to find the Kc. Let me solve the Kc here in the upper part. Kc is equal to, let's write the expression, concentration of NO2 to the power of 4 times concentration of O2, okay, divided by concentration of N2O5 to the power of square. Yeah, and we will put the value here. NO2, it is 1, so 1 to the power of 4, it is 1. O2 is 0.25. All right, divided by N2O5 is 2.5. 2.5 to the square. Okay, now it is just mathematical equation here. So what we got, the result? Okay, this is the result, guys. 0.04. All right. Okay, the result is 0.04 Kc. All right. Do you have any question? Okay, you can write this one in your notebook. Finish? All right, let's continue. I think this is the, just to remind you how to find the Kc. Okay, now we come to the next thing. All right. The next thing is we have another K value. Let me explain first that another K value before this one. Okay, we have another K value. We call this one as KP. Yeah. This is KP is different from KC. If KC is a constant, equilibrium constant in terms of concentration, KC is equilibrium constant in terms of pressure. Okay. Okay, if Kc is equilibrium constant in terms of concentration, Kp is equilibrium constant in terms of pressure. And what is the formula for Kp? It is the same like Kc. But the difference is if Kc is the concentration of product over the concentration of reactant, Kp, we are using the pressure of product with the power coefficient, of course, let's say this X coefficient, over the pressure of reactant. So it is quite similar with the Kc expression, not different, just the difference is concentration changing with pressure now. Okay, is it clear?
Clear.
Okay, this is not difficult. And we have a relation, we have the relation between Kp and Kc. This is the formula. Kp is equal to Kc RT delta N. Kp is equal to Kc RT delta N. Actually, I can derive this formula. It is from PV and RT, but it's very long time to derive the formula. Let's let's accept this formula. But the problem is now, I think you know what is R. R is the ideal gas constant, which is 0.082 liter atmosphere per Kelvin. And T is temperature. Temperature must be in Kelvin. Okay. And delta N, now the problem is delta N. What is delta N? This is the delta N. Delta N is the sum of the coefficient of product minus the sum of coefficient of reactant. Yeah. Delta N is the sum of the coefficient of the product subtracted by the sum of the coefficient of the reactant. It is also clear. So if we see the formula here, if delta N is 0, so what does it mean? If it is 0, then RT will be 1, then Kp will be equal to Kc if delta N is 0. This is also clear mathematically. For example, find Kp and Kc relationship for this reaction below. Okay, it is very easy. Let me write here. Kp is equal to Kc RT delta N, isn't it? Delta N is equal to 2 minus 3. So it is minus 1. So when you put here Kc RT delta N is minus 1. So what will be the last result? The last result will be Kp is equal to Kc over RT. So this is the relationship. Is it clear? All right. Any question about this? About Kp, Kc, the relationship between them? Okay, if there's no question, you can write this one. All right. Finish, guys? All right. Let's continue then. All right. Let me proceed more. All right. This is just only the exercises now. Okay. Then the next thing is, after we know Kp, now we have also variation of Kc. Now this is important, guys. Variation of Kc. We can modify the Kc expression. So the first one, for example, here, the equilibrium constant for the forward and reverse reaction are the reciprocal of each other. So for example, if I have a reaction 2CO plus O2 in equilibrium 2CO2, then let's say that they have the Kc value here, the Kc value, yeah. So for the reverse reaction, if I reverse the reaction like this, 2CO2 in equilibrium, 2CO plus O2 is just I reverse the reaction, the product become the reactant become the product. So what will happen? The new Kc, now it will be 1 over Kc. The new Kc prime, let's say this Kc prime for the second reaction, Kc prime will be 1 over Kc. It is like, for example, do you remember when we reverse the reaction of in the energy? When I reverse the reaction, delta H will be,
Minus.
right? Delta H become minus, right? When it is a positive, when you reverse, then it become minus. In here, it is different. So when you have a reaction, the Kc, let's say the Kc is 4, for example. When you reverse the reaction, the Kc not become minus 4, but the Kc will become 1 over 4. Yeah, it is not become 4, but it is 1 over 4. So you're going to make the reciprocal. You're going to make 1 over Kc, the new one. The new Kc is 1 over Kc. So don't be confused with the delta H. If delta H, if you reverse, then the delta H become the negative, right? Positive become negative, negative become positive, just the opposite. But here now, it is not opposite. The Kc prime, the second Kc, when you reverse the reaction, it will be the reciprocal of the first Kc. I mean, it is 1 over Kc. Right. Is it clear? Okay, you can write in your notebook here now, if it's clear. Good. Very nice. Any question up to here? No? Only 34 students here, but how many students in your class totally in A and B? 20 students, 40 students, isn't it?
Yes.
Yes.
40 students, so 34, 6 students not here. 2 students is permission, right?
Yes.
So 4 students not here. Right. Can we move? Okay.
Yes, sir.
All right, let's move to another thing. Now, the second one, if the coefficient of reaction are multiplied by a number, then the equilibrium constant is raised to the power of that number. Remember in delta H, when you multiply the reaction, the delta H also will be multiple, isn't it?
Yes.
Yeah, in delta H is like that, but in Kc it's different. For example, here I have this reaction with Kc, with the value of Kc, yeah. If I multiple this reaction by 2, for example, if I multiple this reaction by 2, what I'm going to get? 2 become 4, 1 become 2, 2 become 4. So what will be the new Kc? The new Kc is the Kc square of the first reaction. As you can see here, now it is become the square. Kc prime is the Kc square. So it's different from delta H. If delta H, when you multiple the reaction, the delta H also will be multiplied. But in Kc, when you multiple the reaction, the Kc will become the power. If you multiple by 3, then the power Kc to the power of 3. When you multiple by 4, then Kc to the power of 4. Yeah. The factor, the multiplication factor will be the power of the Kc. Okay. This is also not difficult. You can write in your notebook. All right. Can we move? Okay. Very good. Okay, let's move. All right. This is number one, Kc variation. Remember, in the delta H, if you sum the reaction, what will be the delta H? The delta H also you will sum. You sum it, right? The same. Here are different. If reaction equation is expressed as a sum of two or more reaction equation, Kc for the overall reaction is the product of the equilibrium constant of individual reaction. In the Kc, it is not the sum, if, even though you sum the reaction, but the Kc will be multiplied here. As you can see, the new Kc will be the multiplication of Kc1 times Kc2 when you sum this reaction. It's quite different with the delta H. right, can we move? Very good. Let's move, yeah. Okay. Let me see. Do we have anything? No. So this is the last one. Let's do exercise now. For example, here, suppose that the Kc for the reaction below is 4 at certain temperature. Let's say that this Kc for this reaction is 4. Yeah. You will suppose that Kc, this one is 4. So what will be the Kc for part A here?
16.
You multiply by 2, right? So it will be 4 squared. 16, very good. B, right. Let's do B. You can open your microphone if you know the answer.
1 over
32.
1 over 64.
Yes, very good. It is 1 over 64. Because what you are doing, first you reverse the reaction. When you reverse the reaction, it is 1 over 4. And then after that, you multiply by 3. So you're going to power it by 3. So it is 1 over 4 to the power 3. So it is 1 over 64. Very good. C,
1 over 2.
1 over 2. You reverse first, isn't it? You reverse 1 over 4 and then multiply by half to the power of half. So it is 1 over square root 4. So it is 1 over 2. Very good. You get the answer for this? Okay. Yes, this is the answer. Right, now another reaction here. Okay. Any answer?
8.
So what do we do here?
Reverse.
For the first reaction, you reverse. Very good. Second reaction, it stays.
8.
Okay. So when you reverse this one, so this is 1 over 4, isn't it? 0.25 is 1 over 4. So when you reverse it, it's become 4. When you add that reaction, then 4 times 2, it is 8. Very good. So like this, for the first reaction, you reverse 1 over 0.25, it is actually 4. Yeah, it's equal to 4. And the second reaction is like this: when you add sum, you sum these two reaction, what will happen is cancelled NO, NO2 also cancelled. So you will get this overall reaction, and Kc will be this the sum of this Kc1 time, sorry, not the sum, the multiplication of Kc1 times Kc2, and you will get 4 times 2 is equal to 8. Very good. All right, we finished the topic. I'm not going to come with this one. We are going to do it in a normal lesson. Do you have any question, guys? Let's see that is there any other question that we haven't solved. This is resolved. This is resolved. For example, this question. Example number 12. We still have time. Let's solve this. Example 12. Any answer? Okay, did you write the question? I have more space to solve this one. Okay, let's do like this. How many time we have now? We have under 4 minutes. Okay, let's do like this. Okay. So I'm not going to write. I'm going to show you the answer for this. Okay, the question is 4 mole. NH2 is given, total pressure at equilibrium is given, and total mole number at equilibrium, oh sorry, the number of mole of N2 is given. The question is Kp. So we are going to write the matrix, the same thing. Yeah, here is the solution. You're going to write the matrix initial change in equilibrium by using the mole. Initially, 4 mole is given in the equation, and 1 mole is given at the equilibrium. So 4 and 1 is given. So you can find the change here. It is obviously +1, then it is +3 because of the coefficient. This is -2 because of the coefficient. So you get the equilibrium mole number 213. Okay, and then you convert it into molarity by divided by the volume. The volume is given also in the equation. So you will get this molarity to 2/2, 1/2, and 3/2. And then what we are going to do, PV is equal to nRT. This is, we have this formula. Do you know this formula?
Yes, sir.
Okay.
Yes, sir.
The total pressure is given. This is at equilibrium, yeah. The total pressure is given 3.6, and volume is also given 2 liter. Total mole number at the equilibrium, it is given by here, not given. Sorry, you found this one. 2 + 1 + 3, it is 6 times RT. From here you got the RT. What is RT? RT is equal to 1.2. And from this concentration here, you can find the Kc. Kc is equal to concentration of product divided by concentration of reactant. And you know the concentration here, you got the Kc value here. And by the formula, Kp is equal to Kc RT delta N. Yeah, Kc is given. Kp is equal to Kc, you put it the Kc, and RT, you know the RT by this formula, RT 1.2. And delta N, you know, from the coefficient here, delta N will be -4. Sorry, 2. 4 minus 2 is 2. Then you calculate that one, you will get 2.43. Okay, I'm going to give you this question in the class next week. That's enough for today. Thank you. Hope you are start to solving problem from your book. See you next week. Have a nice weekend. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.